This is a demonstration of the 3D implementation of the CityBlock algorithm using the processing language. What you're seeing is the initial screen that comes up when the program is first launched. And what we have here is a collection of, or a grid of white cells, which are healthy, non-feature cells, and then some randomly generated growths that are sort of like a cancer tumor. And in this case, you can see that these are probably two growths that have kind of merged together to create a more chaotic looking shape. The intensity of the cell and the redder it gets, that is an indicator of how far it is from the nearest healthy cell. So these light green colors, they basically neighbor a healthy cell, and this brighter red is approximately 4 steps away from a healthy cell. So the first thing we want to do is maybe drag the picture around a little bit and look at what other feature cells we have. We can tell there's another relatively large one there real fast just by looking at the color. But there's probably quite a bit going on inside that we can't see. So we'll separate this by just one step to keep it a little bit small and manageable. And you can see that these feature cells that you see on the face actually have quite a bit more going on behind them. For example, this particular cell, you can tell here he's got the origin of it is actually on the inside, and that's the largest distance feature for that particular growth. So the next thing to try and do is to remove a cell. And this is essentially like treating a cancer growth. And what we want to do is the algorithm is going to find the biggest distance it can across all the cells, and then it'll find the first cell who has that value and remove it plus all of its neighbors. And we've intentionally done this in a kind of direct fashion so that you can reset the image and know that the same number of steps will occur each time in the same order. Part of the reason is because when you remove a cell, you recompute the distances, and then that changes all the other cells, or has the potential to change the other cells around it. And we want to make sure that your results are repeatable for a given image. So if we remove the first feature, now you can see we couldn't really see one disappear, so this is a good example of wanting to be able to repeat it. And if we look around, oh, okay, there it was in the back. So now if you really wanted to watch this be repeated, you'd say, okay, I'm going to reset this. It puts all the data back how it was, and then leaves your view the same so that you can watch this corner and this side as you remove a cell. So we're going to remove that feature. Sure enough, there it goes. Now, another thing that's interesting to do here is we can turn on the removed cells, and this allows us to kind of examine a little more closely where all the cells disappeared from. It can be a little tricky with the 3 dimensions to be able to tell exactly what everything was. So we can turn those on. We can also turn on a sphere that replaces the area that we've removed. And now one thing you'll see here is the sphere obviously is clipping into a healthy cell here. And if there was another sphere close by, it could clip into that as well. And the reason for this is because the CityBlock transformation is very stepwise oriented. You move one step down and one step over, and circles don't really like to be drawn in that fashion. And so there's an unavoidable clipping here. However, it does not mean, as you can tell if we turn the spheres back off, that anything actually happened to any of those cells that it was touching. They're still considered to be a healthy cell. They're still part of the image. It just so happens that the sphere covers it. And then we can continue. Let's turn off the removals. So we'll continue removing a feature. So the next one that was removed was up here on the top. And if we draw another sphere, we toggle our spheres again. Now we have 2 large spheres that are coming right up against each other. They might even be intersecting. It's a little bit hard to tell. So we'll continue then with removing the rest of our features. And you can see now we have 3 basically large spheres along with one kind of medium-sized one. And this shows all the spherical removals that we've accomplished. So now we can generate new images, and don't be fooled. This isn't a blank image. If we look around, we can see that it's got quite a few features. And again, pointing out the separation, we don't make single cell features, so we know there's something going on in there. We zoom out a little bit, or expand it a little bit, and we can see those images.